All right, so back for one final speaker, and then we're going to have a panel discussion. And here we have Adam Horner, with more than 30 years within IT and more than 10 years working as a CTO. He's now working as a fractional CTO, helping startups to make the best strategic choices possible. And with a dash of history and all those silver bullets, he will give a talk about AI for software and where do we go next. Round of applause.
So how much is AI going to change the profession of software engineering? I'm going to try and explore this by looking not forward, but backwards. My name's Adam. I'm a fractional CTO, which means that I work part-time as a CTO for multiple companies at the same time. We'll come on to a little bit more about me. We're going to go through the history of software engineering, a little bit about the history of artificial intelligence, and more importantly, what does it mean for us? So my first job was as a sysadmin in 1995. That means it's almost 30 years, not quite yet. I have a degree, a bachelor's of engineering in computer science, learning the art of code, right? And that contradiction in terms is pretty much the heart of where we get to with AI and coding. First time as a CTO was as a co-founder, basically 10 years ago. And now, as I said, I'm working for 4 companies. And I can talk to you about what a fractional CTO is and what it does afterwards if you're interested. The interesting thing about this is it gives me the unique distinction that or not unique, but fun distinction that I graduated last century. So with that little bit of history then, let's get into some of the history of computer science, or the software engineering in particular, I should say. So first of all came the dinosaurs, then they died, they turned into oil. We mined oil and it became one of the most valuable things on the planet. And then we realized that data was kind of more important than oil. So, data is the new oil was the new thing. And then we had the first major data spill. And that was nothing to do with AI. That was just humans. There was a bit of a glossy and far too brief view on software engineering and the history of it. So what we'll do is we'll cover, instead of that large range, narrow it down a bit and cover the commercial history of software engineering, which sort of starts in the 60s, really, with the Apollo missions. Does anybody have one of those digital watches? Not like a smartwatch like this one, but the one with a little LCD display. No, you remember those ones? There is more computing power on one of those than there was on the Apollo rocket that took people to the moon for the first time. And in terms of the history of software engineering, we're looking at 60 years here from there to the current, about 70 years from there to the current date, right? If you do civil engineering, you've got a history that's about 2,000 years long as a profession. Military engineering, you're talking about 2,700 years as a profession. So this is one of the youngest things, right? People go to the university to learn the history of art. There's no such thing as a history of software engineering yet. So we'll just quickly cover a few things here. So we had the Apollo missions. It wasn't until 10 years later that C as a language is invented. Source code control, late 70s. That's as recent as it is. There's a picture of the penguin up there. Linux actually came way later than this, but Unix, yeah, late 70s. Case tools. Does anybody know what case tools are? I'm showing my age here. Computer-aided software engineering. Basically, it was visual tools. Today, we'd call it an IDE, or a ticketing system, or a process for reviewing code. The capability maturity model was something that was developed by the US military to figure out if software engineering companies were any good. Not like remotely good, any good at all. C++, we think of sort of the grandfather of object-oriented languages, late 80s. We're already halfway through the commercial history of software engineering. Then comes the web and Java. Yeah, if you work in enterprise. JavaScript, not so good if you like type safety. Design patterns book, right? The Gang of Four. Pretty much required reading by any software engineer. Learn your design patterns, they're crucial for everything. That only came in the 90s. How many people use Jira? How many people hate Jira? Right, Jira is 20 years old, right? And the Agile Manifesto predated Jira. So the first versions of Jira didn't do Agile at all. It only did the waterfall model. It was actually, for those of you who were interested, it was actually a plugin to Jira called Greenhopper, which Atlassian eventually bought and integrated into the platform, one of the best things they ever did. And then cloud computing came along. I've actually borrowed this graphic from a boot camp, so apologies, the last graphic doesn't really represent cloud computing at all. But see, the thing about this history is the first half of that history, the 60s, the 70s, and the 80s, was utter chaos. And what I mean by that, it was called the software crisis. There were thousands and thousands and thousands of lines of journalism written about the software crisis and how software was terrible. It was more expensive to own and support software than it was to build it back then. Any software. Most software projects overran on budget and time. Most of it was full of bugs. Lives were lost due to programming errors. Like simple things. What we think of today as simple things. Radiotherapy, people were given massive overdoses because of a couple of lines that had the wrong semicolon in it. People perished. So in 1987, we heard about the silver bullet coming up here. Here's the silver bullet. The thing is, there is no silver bullet. At least that's what Turing Award winner Fred Brooks wrote about in 1987 in a really great article. Go look it up. The No Silver Bullet is worth reading. It's not that long. He goes into some depth, but he says there's no single development in either technology or management technique which by itself promises even one order of magnitude. That's a 10x improvement within a decade in productivity, reliability, or simplicity. So what does that mean for AI and software if there is no silver bullet? In the paper, actually, he goes on and actually addresses AI directly because the history of AI goes way back before this. Incidentally, 1987, the same year this paper was released, was also the first year that anywhere in the world a degree in software engineering was available. That's how young software engineering is as a professional endeavor. I actually studied at Imperial College, the Department of Computing, Imperial College. It's an academic institution in the UK. It had the worst email addresses. How many people have a really bad email address? Yeah, try having an email address that's doc, ick, ack, arc. Another law about the same time, Moore's Law. I'm sure everybody's heard of Moore's Law, right? How many people think Moore's Law is broken and it's been disproven? Actually, it still holds true now. This is really hard to see, so I'm going to try and sort of highlight some of these things on here. Put the point in the right place. So, on here. So these little points down here that are sort of below the main line, these are the ones that are built by ARM, the low power processors. And that's the only reason they're on this list, is because they, rather than pushing the envelope in terms of amount of computing power, it was sort of the low power aspects of them. And in fact, Apple's M2 appears somewhere around about here in terms of its computing power. It's one of the most powerful single chips available right now, but it's following Moore's Law as well. So there's something about the laws that were written back in those 80s and 90s that are pretty much holding true even now. So AI then. How many people recognize this image? Good. So this is otherwise known as the Turing test. We're talking about general AI here. So in 1950, right, so way back before the beginning of that diagram in terms of history, Alan Turing, mathematician and scientist based in Manchester at the time in the UK, wrote a paper titled Computing Machinery and Intelligence. And the famous opening line in there is, can machines think? He didn't try and answer that question. He tried to answer a different question, which is basically the imitation game. Is if a person C is in a room and can communicate just via text to two entities, one is a person, one is a computer, they can pass the imitation game if person C can figure out which one's a computer and which one's a person. Arguably, for certain variations of person C and use cases in the A and B, there are things out there that can pass the Turing test. But generally, most people agree that nothing yet quite passes the Turing test. So when you're asking ChatGPT to build your code, spinning that wheel of fortune on the code, can you think about whether that code is written by a person or by a computer? Sure, it's fast. Is it accurate? Is it right? Sometimes, as we saw. Sometimes not, as we saw. So the history of AI then has a pretty long history. And we also tend to think about AI as being one thing, whereas in reality, AI is a lot of things. This is the Gartner hype cycle. How many familiar with the Gartner hype cycle? Let me quickly talk us through it then. On the left-hand edge, we have sort of the beginning of the innovation, the idea, the seed, where somebody comes up with this idea, we could do this thing. So for AI, it doesn't exactly start with Turing, although he was the first person to sort of make it start being in the popular thought process, especially amongst computer scientists. I mean, arguably, AI starts as a concept back in 1637 with Descartes. But that's a whole nother story and a whole nother talk. So then we have the peak of inflated expectations, right? We're talking, flying cars in the 1960s. Are we still waiting for them now, right? Inflated expectations not got there. We had the trough of disillusionment, right? That's crypto, right? Just now. How many people invested in crypto? Oops. But then we get to the interesting bit, which is the interesting bit is the slope of enlightenment. This isn't sort of a Buddhist thing. This is literally where people are beginning to take advantage of the tools as they are. So as we heard earlier on, it's not just about doing what we used to do with Google and trying to do it in ChatGPT. This is actually using it as a tool for what it is and exploiting it in the best way possible. And this Gartner's hype cycle here, this was actually launched middle of last year. And I've still got those pointer up. If you look at this bright blue dot up here, that's generative AI. That describes pretty much exactly the category that ChatGPT fits in. And they had it back then, 18 months ago, still at the sort of the peak of heightened expectations. Therefore, the trough is going to come. And yeah, you could say that we're kind of there now because people are saying, it doesn't actually make sense. It tells people that they can walk across the channel too fast, etc. But I think the point is that people are now beginning to figure out how things work. And it's going to take, based on what we saw with a lot of those other technologies, 5 to 10 years or so to do that. So how did we get here then? So we've got our history of only about 60 years with an accelerating set of tools and utilities, the first half of which was pretty much chaos. It's the Middle Ages of computer engineering, right? The concept that there is no silver bullet, no one thing is going to make a 10x improvement in a decade. We got our test for what good looks like, written before our history even starts. And we've got a hype cycle that people are getting really excited about this stuff. We're clearly a big peak at the moment. Thank you, ChatGPT. So what does that mean for where we go next with respect to AI in software engineering? Well, it's here to stay, right? It's not going to disappear. Thank you, OpenAI. So my suggestion: start practicing. Find an excuse. Convince your team lead, your CTO, your boss, or don't and just do it anyway. It's on the internet after all, right? It's available to everybody. I think one thing's for certain, there's going to be a lot more investment. I think OpenAI, with their $1 billion investment from Microsoft, that's actually the second round that Microsoft have done in OpenAI. And I think that's probably going to be on the small side compared to some of the investments we're going to see coming up in the general space. Investors love flocking after things. They've all chased after crypto, and now they're chasing after AI. It'll last a while, I think. I think the other thing that's interesting about AI is I like to think about AI now as almost like a human anatomy. ChatGPT is like the mouthpiece. You can chat to it and it talks back. We've got predictive AI, which is like the brain, right? But there's a whole lot of other things that make an autonomous being work. And if we think about the human body, we have an autonomous nervous system, we have digestion, we have motor facilities. There's an awful lot of other things that might need to go into creating a system of a general AI or even specialized AIs that work more than 50% of the time. So what can you do next? So if you're looking for a new job, I've got a couple of points that might be interesting. Ask the hiring manager what training you might get in AI, or what experience you'd be exposed to in the usage of AI in your new job. It'd be interesting to hear what they say, because very few hiring managers will have had this question yet, so it'll give you a head start just by looking smart. You can also ask them about what their policies are around AI. And again, they probably won't have any good answers. They probably won't have any answers at all, so you probably catch them on the back foot. But again, you'll be looking smart. But there is a serious point to this, because there are going to be some organizations that are going to be sort of forward-leaning and go, go for it. Experiment with it. Tell us how it works. And there's going to be others who are going to go, no, don't do that. Right? So if you want to work with AI, I'd say go look for a startup. If you want to get lots of different experiences of working with different AIs, go work for a consultancy. Forget asking the boss, do it anyway. If you want to do a lot of different AIs, go work for a consultancy that works for startups and you get the most exposure to it. If you don't want to work with AI, and there'll be some people who really don't, right? Maybe some people come to you and say, how do I avoid this AI stuff, right? I'd suggest go working in defense. Real-time systems, like airline control systems, or something heavily regulated, like, I don't know, health tech. Because a lot of those areas, they can end up with a lot more scrutiny on the code that goes into the platforms and correctness proofs about the result of their software, right? They're probably going to be a little bit more fussed than you would be about generating a beautiful profile for your coders. But there's also a lot of natural fear around AI. What could possibly go wrong, right? If anybody hasn't seen the trailer for Megan yet, go watch it. It's terrifying. Yeah, who recognizes the first one there, the one on the left? Very good. There's a few sci-fi buffs in here. That's HAL 2000, HAL 9000, sorry. Skynet, obviously, in the middle from the Terminator series, and then Megan is a movie just about to be released later this spring. But seriously, don't panic, right? This is from The Economist this week, basically saying, don't fear the jobs apocalypse just yet. The computers aren't going to take over. In fact, they argue that it's not that we should be scared of the automation. They use all sorts of metrics like demographics, economic success, growth, etc., to show that actually what we need is a lot more automation and a lot more smarts. So make the most of it, take advantage of it. Thank you.